In this introduction to factoring, you will factor trinomials of the form x squared plus bx plus c. You will also factor completely a polynomial that has as a factor a difference of squares or a trinomial square. To factor trinomials of the form x squared plus bx plus c, you want to find two numbers that multiply together to give you c, but add together to give you b. This is only going to work when the coefficient of the quadratic term is 1. So when they're in the form of x squared plus bx plus c, with no coefficient in front of the x squared other than 1. So for example, we want to find two numbers that multiply to give you 6, but add to give you 5. So I'm going to just list the factors of 6. We have 1 and 6, and we have 2 and 3. Well, 2 and 3 are the ones that can be added together to get 5. So we're going to go with these. So now when we factor this, we're going to write it as two binomials multiplied together. It's going to be an x here and an x here. That's going to give us the x squared. And now to get the 5x and the plus 6, we want to have a plus 2 and a plus 3. And you can check it by using FOIL to go back to what we started with. First 2 is x squared. Inside 2, or sorry, outside 2 is 3x, and inside 2 is 2x. So 3x plus 2x is 5x, and then the last 2 times 3 is 6. So that's how you factor x squared plus 5x plus 6. Now for our next example, to get x squared, I know it's going to be an x and an x here, but now to figure out the rest of it, I want two numbers that when multiplied together give us 12. So 1 and 12, 2 and 6, or 3 and 4. And we want to know which one of those pairs will add together to give you 7. So it's going to be the 3 and the 4. But we're actually going to want to put subtraction signs in here instead of addition this time, because when we multiply the last two, -3 times -4, that'll give us our positive 12. And then when we do the inside 2 and outside 2, -3x and -4x when added together is -7x. So this trinomial factored is x, the quantity x minus 3 times the quantity x minus 4. Now for the last type of problem that we're going to work with, we're going to factor these completely. When I see 3x squared minus 75, the first thing I notice is that I can pull a 3 out because that's a common factor of both terms. If I pull out a 3 or divide each of these by 3, I end up with x squared minus 25. This right here is what we call the difference of two squares, because this is squared and this is also a perfect square. X squared minus 25, what that can factor to is, if I take the square root of x squared, it's x, and the square root of 25 is 5. Now I want to make one a plus and the other a minus, because watch what happens when you go and perform FOIL on this. You get x squared, and then you have a positive 5x and a negative 5x. And when you add those together, you end up with 0 x's. So that middle term is gone. And then positive 5 times a negative 5 is negative 25. So factoring this completely, we ended up with a monomial times a difference of two squares, and the difference of two squares can be written as the following. So there's your final answer there. Now in our last example, if I look at each one of these three terms, I can factor out a 5, which is going to leave us with 5 times the quantity x squared plus 6x plus 9. And now this right here can be factored doing what we did up at the top. If I look for what two numbers I can multiply to get 9, but add together to get 6. So we have 1 and 9, 3 and 3. It's going to be the 3 and 3. So x plus 3, and then also x plus 3 again. Once again, you can check this because x times x is x squared. Then the inside 2 is 3x, and the outside 2 is also 3x. And when you add those together, you get 6x. And then the last two, 3 times 3 is 9. So you could write it as this, or you could say 5 times the quantity x plus 3 squared.